Here's a quick significant figure review. We'll talk about how to read measurement scales. So not like scales that you measure weight on, but all scales for volume, for mass, for length. Okay, and here's the deal. You always estimate to one more place than you know. And what we mean by place is if you know the tens place, you'll estimate the ones place. If you know the hundredths place, you'll estimate the thousandths place. And then significant figures in measurement show all the certain digits plus one estimated digit. Let's look at this length, this ruler, which is a centimeter ruler. Okay, so this is the 0 mark, though it doesn't say 0, it should. This is the 1 centimeter, here's 2 centimeters. So when we're looking at this, we definitely know we're past the 1 centimeter mark. So we'll do 1 point. And then we can estimate, or we can actually figure out this is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. You can see it's a little bit past the 7. So we know we're at 1.7 something. And then to me, it just looks like I'm a little bit past that. So I'm going to call it 1.71 centimeters. Okay, so you always put your units there. And somebody else might see this as 1.72 or maybe 1.70. This estimated digit can be a 0 as well. If it were a little bit further, it would be something like 1.74 centimeters perhaps. But this digit that I'll highlight, this is your estimated digit in this case, and then the other two are certain. In the case of the graduated cylinder, this is a bit of a different scale. By the way, on a graduated cylinder, you always read from the bottom of the meniscus, so down here, not up here. So 10, and then there's a 1 millimeter marking in between. So we know we're at 30. We know we're at 35 here, 36. This looks like it's in between 36 and 37. So in your head, you have to split up the 36 and 37 into 10 equal spots to figure out what you would write for the volume measurement. So I think this looks like it's at 36.5, and then the units are milliliters. Okay, so notice that this one went to 2 decimals, this one only goes to 1, and that has to do with the precision of the instrumentation. So again, this is our estimated digit, and this is 3 significant figures. Lastly, we'll look at the balance here. So this is electronic. The good news is you don't have to do any estimating on your own with a digital piece of equipment, but this still has an estimated digit. The estimated digit is the last one, okay? And then the 5 and the 6 are certain, they're known. And again, this has 3 sig figs as well. Now, not every measurement will have 3 significant figures. It just so happens that the ones I chose do. So how do we know which digits are significant? Any 1, 2, 3, 4, 5, 6, 7, 8, or 9 is always significant in a measurement. And that leaves zeros. Zeros are complicated because sometimes they're significant and sometimes they aren't. So any sandwiched 0 is significant. Any leading 0, meaning out in front before the first 1 through 9 number, never significant. And then zeros after the last 1 through 9 number can be significant or they cannot be. What you need to look for is a decimal point. Okay, so let's do a couple examples. All right, so here I'm going to put a check mark above each significant digit. So the 1 is significant, the 7 is significant, and because this 0 is sandwiched, it's also significant. So we have here 3 sig figs. In the next one, definitely the 4 is significant. Now we have 3 zeros at the end. So we're going to be looking at this last rule. Zeros after the last 1 through 9 are only significant if you see a decimal. So since you don't see a decimal point here, we only have 1 sig fig, and it's our 4. So those zeros in that case are not significant. In our next example, obviously the 6 and the 3 are significant. Now we have to figure out zeros. So these zeros are out in front. Leading zeros are never significant. They're placeholders, they're important, but they don't count as sig figs. So you only have 2 sig figs in this measurement. In the last measurement, obviously the 2 and the 9 are significant, and now we have a 0 at the end. Okay, let's go down to this last rule. Zeros after the last 1 through 9 digit are significant if a decimal point is used. We see this decimal point, and because of that, that makes the 0 after the last 1 through 9 significant. So here's an example of 3 significant figures. This one happens to also be in scientific notation. This doesn't affect your sig fig. It's just what's out in front of the times 10 to that. So when we're doing calculations with measurements that we've taken, those measurements are going to have a certain amount of significant figures. Your answer or your result of a calculation can never be more precise than the measurements that went into that calculation, which should make sense, right? You get a number on your calculator and it has like 10 decimal places. You're not actually going to write all that down on your paper because there's no way we could have measured, a mass or a volume or whatever you're doing to that precision, to that level of precision. So when you're doing addition and subtraction, there's one rule, and it's round the answer to the fewest number of decimal places. That's actually not exactly the rule, but it'll get you there. So if we do this calculation, 13.98 grams minus 6.88, this number has 4 sig figs, this number has 3 sig figs, but that doesn't actually matter. What matters is the number of places after the decimal. So here we have 2 places after the decimal, here we have 2 places after the decimal, meaning when we do the subtraction, we're going to get 7.1. That may be all your calculator says, but you actually need that second digit after the decimal, so put a 0 there as a placeholder. It's also a significant figure, 7.10 grams. And now we'll do the rule for multiplication or division. So here we do care about the total number of sig figs. So in our top number, we have 4. In our bottom number, we have 3 sig figs. So we want to go with the fewest, which is 3. So we're going to round our answer to 3 sig figs. So when you do this division problem on your calculator, you should get 0.17825, blah, blah, blah. So if you come in and say, okay, I want only 3 significant figures, start at your first sig fig. This 0 isn't significant. This 1 is. So you're going to start there, count over 3. 1, 2, 3. Ask yourself, does this 2 round the 8 up? The answer is no, it does not. So your final answer here would be 0.178. And then the units, it must be a density, are grams per milliliter.